I have done enough work, these kind of works, and I don't want to do them anymore. And after we finish this one, we can start the next guy, which is a lot nicer, I think. So here we go. The last couple of questions are to do with emptying water out of tanks. So we did a similar one to this. And then there's another one after this underneath this piece of paper. And that's kind of the work done. So in this one, it's a cylindrical tank. The density of water is 62.5 pounds per cubic feet. And we're told that in the question. And we're also told that the depth of the water is 5 feet. So it basically goes up to about here roughly. And we're going to calculate how much work is going to be needed to empty the tank. So to remind you how you go about this question, same question as last time, just different numbers. Take a horizontal strip at some position X from the top. So if you imagine that's the top and you go to here, you've got a little strip going like that. And it's a very thin little strip. There we go. And it looks something like this. And then you find the volume of this strip. Well, its volume, because it's basically a cylinder, is pi r squared h. That's pi. The radius is 12. And the height is delta x. And you get 144 pi delta x. And then you find the weight of the strip. And basically that's where the 62.5 comes in. So it's 62.5 times the volume, which is that guy. So far, so good. Then I grab this calculator and just multiply the numbers together. And I have 62.5 multiplied by 144. And I get 9,000. So 9,000 pi delta x. And pretty much the question's over with. This piece here is basically our force function. So all you need to do then is integrate that guy. The delta x essentially becomes a dx. I believe these questions have a sigma thing going on. You remember that sigma thing that they do with Riemann sums? If they don't, that's great. But if they do, then you just call this thing 9,000 pi and you're done. And since there's only 5 feet, we're going to do from 1 to 5. Oh, 1 to 5? Sorry. 1 to 6. Right. So it's going to be 1 to 6. And it's that way around because the water gets sucked up from the bottom up. And that horrible thing, you then calculate. So I'll give you a few seconds to write down whatever you want from that one. It's really just another carbon copy of emptying a tank that's full of water. Second guy is an aquarium. This particular one is 5 feet, 5 meters, I should say, by 4 meters by 1 meter. And we're going to find out in this question, they want to know not how much to empty the whole tank, but the work done in emptying half the tank. So that's what we're going to calculate. So just like over here, you pick a random little baby strip and you make it X units from the top. And this strip is going to be delta X, and you end up with this little guy. Looks like a piece of bread to me. And you find its volume. Now, in this case, would you give the volume as length times width times the other guy? So it's going to be 20 delta X. That's the volume. Now, if you want to get the weight, if these units were in feet, I just multiply the volume by 62.5. But since these dimensions are in meters, we use this information, which they give you. I'm assuming that you knew that there was 1,000 kilograms in a cubic meter of water. Right, you knew that? Right, because it's basically 10 meters by 10 meters by 10 meters, right? That's what you get. And gravity is 9.8. So if you want the weight, it's gravity, mass, times volume. And you put that package together, you get even bigger number than the last time. You get 9.8 times 1,000 times 20. And this ends up being 196. All these zeros, delta x. And this bit is our force function. And oh, I forgot my x's. Shame on me. I forgot to do the depth, so I'll stick my x in here. There we go. Did I do my x's here? Oh, forgot my x's here too. Don't forget your x's. The x's is the depth of the water that that strip is on. So that's how much distance you have to move the water. So don't forget your x's, as I just did there. And this is some ridiculously big number. Now, you only want half the tank. Now, if I wanted the whole tank emptied, wouldn't it just be 0 to 1? But I want half the tank emptied. So how about 0 to a half? Because it's half a meter. If it was 5 meters deep, it would be what, 0 to 5 halves? Okay, I zoomed through those guys because I feel we've done a lot of time on these and we have to move on. Obviously, this video will be online so you can check it out. So, and call that good. We are ready for our next section, which is much more interesting for me. Hopefully for you. And we are going to do section 6.5. And it's called the average value of a function. So we've left behind the physics class, which I don't mind telling you I'm happy about. And we're going to move back to real calculus, right? Things that have x's in them all the places. So here we've got a function, and I want you to imagine I have a function that starts here and it finishes here. So it starts at A and it finishes at B. Now, if you're trying to imagine what is the average value of a function, can you imagine that various places, the height of this function takes different values, right? Now, normally when you get an average, don't you add up all the things and divide by how many there are? Now, that's okay if there's only 10 numbers, because you add up 10 numbers and you divide it by 10. But you can't really add up an infinite number of numbers, right? An infinite number of heights and divide by infinity. That tends to cause problems. But thankfully, there is a formula that allows us to get the average height, the average value of this function. It's called FAV. You'll also see it in some textbooks called that. And so the average value of a function, so this is a number. It's essentially that guy. Kind of makes sense, you know, why that formula is the way it is. Isn't this bit kind of what you'd get if you added up all the heights? And isn't this dividing by the width? So the average height divided by the width. So that gets you what's called the average value of a function. Can you imagine that this function was the temperature in a place from midnight to noon. Then what you're going to calculate here is what the average temperature during that 12-hour period is. So if you want to get a kind of heads around what's the average value, there's one way of looking at it. Now, the application of it is very easy. Isn't that just an integral? And isn't that just a fraction? So as long as you tell me f of x and where a and b is, won't this really just become a good old-fashioned find an integral? Right, so we don't need all this 9.8 and 62.5s and is it the top half or the bottom half and all that annoying stuff. This is much cleaner. It's pure math. So I'm going to start you off with a baby one, just to get into the swing of things. This is eversion question 1. We're being asked to find the average value of this quadratic. And we're being asked to find the average value of this quadratic from -1 to 3. So essentially that's my A and that's my B. So let's see what the average value looks like. It's 1 over B take away A, the integral from A to B of the function. And that's 1 over 3 take away -1. The integral from -1 to 3 of this function. Three take away -1 is a quarter. Would you agree this integral is a baby integral? Isn't this just power rule? Right. So add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and evaluate it at -1 and at 3. So the average value of this quadratic in that range of x's is going to be whatever this ends up. So it's going to be 1/4. If you plug in 3, it's 3 cubed plus 4 lots 3 squared. Take away -1 cubed plus 4 lots of -1 squared. That's 9 and that's 36, so that's 45. And that's 4 and that's -1, so it's 3, so you're going to take away 3. So it's going to be 1/4 of what, 42. Well, it's a bit messy, isn't it? It's 21/2. Are you comfortable that this is a very much just a procedure, isn't it? A formula with a chug and plug. And as long as this function isn't too weird, these should be relatively quick to do. And in the first, whatever, half to 3/4 of the questions are just going to be like this one. You'll be given a function, you'll be given the interval, and being asked to calculate the average value. So what can make life difficult for these questions? Well, couldn't you get a really ugly thing to integrate, which might make your job a little bit more difficult? So let's pick one that's ugly. And the guy I'm going to pick is this one. We're going to find the average value of this function, and we're going to do it from 1 to 3. There's my A, there's my B. So the average value is that guy, the integral from A to B of our function, dz. We need to integrate e to the 1 over z divided by z squared. How am I going to do that integral?
You sub the 1 over z.
Correct. Why did you choose that one? I mean, what made you say, yeah, that looks like a good use of? Because it's correct. Why did you do that? I guess it could be. Is it just your brain told you it was a good candidate and it might work?
Because it's the ugly thing over the e.
Yeah, E, the ugly thing. Ugly thing is a good candidate for the use of, isn't it? E, ugly thing. E to the 1 over z is the ugly thing. And there was an alternate that doesn't work. Couldn't you have picked z squared as a u sub? Can you trust me that if you did that, it doesn't come out nice, and so you throw it away and you go somewhere else? So you may, when you do u subs, there may be a couple of choices, but very often only one of them works. And hopefully, if you pick the wrong one, you know it and you can go back to the question and pick the right one. This one's a little bit messy for other reasons. Since I have to differentiate that, I'm going to rewrite it as z to the -1. That way, when I differentiate it with respect to z, can I just use the power rule, which is multiply by the power and reduce it by 1. And then for algebra reasons, I'm going to turn it back into that guy. Then when I do my crossover, I get z squared du is negative dz. And when I isolate my dz, we get that. So we have got 1/2 the integral e to the u over z squared times negative z squared du. And this becomes cancel, cancel. That guy. And isn't that normally a good sign when you do a u sub, you get a guy that looks like this? So what we need to do now is I'll bring it in, take it out. It's hardly worth the difference. I'll keep it out since it's there. It's going to be negative e to the u. And then I'm going to return it back to the z's. And then I can put in the z equals 1 to z equals 3. And we get 1/2 negative e to the 1/3. Take away negative e to the 1 over 1. I'm just making this look pretty. We've got this guy plus e. And although that is correct, and I don't think anybody would take points off you, I probably wouldn't as well. But doesn't it look just slightly prettier that way around? So the average value of this function is that number, at least in the range 1 to 3. Before we start looking at some of the other questions, here's a couple of rules about the average value of a function. You can only use this formula when this function here is a well-behaved function. Now, a well-behaved function is just a mathematical way of saying it's not going to do anything weird. So it's continuous, it's differentiable. And in my brain, it's just a nice curvy curve, right? Don't try and use this rule if there's a vertical asymptote. Can you imagine the problem a vertical asymptote might have on the average value of a function? Couldn't the average value of a function be infinity then? Because, you know, vertical asymptotes do weird stuff. So don't try and use it with vertical asymptotes. Don't try and use it with any kind of weird function, essentially. They're not going to give you any of those situations, but be aware that this rule or this formula only works for well-behaved functions, as you'd expect. Any questions before we start showing you some more of these? Nice, simple, straightforward function. Mostly, isn't this mostly practice at integrating? So what I'm going to do is I'm going to jump over now to the homework, and we are going to look at what techniques you would use to integrate it. Let's get that solution out there. It's annoying having that around. Okay, we're good. No, we're not. Why is it not going away yet? There, we're ready. Yeah, and try that again. Here we go. So there's a version of 1. We've already done that. Okay, you're doing question 2 right now. Imagine that was your question. All I want to know is, how do you integrate the square of x? What would you need to do? Square of x, what would you need to do?
Raise it to the half power.
Yeah, and then it's a power rule. Would you agree that one's a baby question, right? There's the guy we've just done. Okay. What is the integral of 2 over 1 plus t squared? That is a guy you should know. 2 over 1 plus t squared.
Isn't it the inverse tangent?
It is inverse tangent. And did you notice that you're all using inverse tangent to make me happy? And nobody's using the other word I refuse to say, that one. What would you have to do in, what question is this? Question 6. What are you going to do to integrate that guy?
Substitute.
Okay, what's your u sub going to be? You're right, but what's it going to be? I lost you.
X cubed plus 36.
Agreed. Not x cubed plus 36 all squared, but just the x cubed plus 36. Agreed? If you tried the other one, a couple of lines later, you'd realize it wasn't going to work. There's a sneaky one. What u sub should you use in question 7? I guess there's 2, maybe 3 candidates, but really 2, and only one of them works.
Would you use cosine of x?
Correct. Why that way?
Because if you use sine, there's no way you're going to be able to cancel out 4 other cosines using the u substitution.
Right. So sometimes then you have to use, yeah, exactly what she said. So sometimes you have to look at a question and not just look at the u sub, but look at the other bit, because that's part of the puzzle, isn't it? And won't a cosine get rid of one side once you use it as your u sub? What's the u sub going to be in question 8 then? What's the u sub you should use in question 8?
Natural log of u.
Correct. Isn't the only other candidate u? Would you agree a u sub of u? I guess I should call it a w sub, shouldn't we? Because u is already the variable. So the w sub has to be log u. You can't use the other alternate, which is the bottom, because that just gets you back to where you started. Would you agree that question 9 is just call it t to the -2 and the power rule will work? What would you do in 10? Oh, that one's got you. I wonder why.
Just FOIL it out.
Right, that would work. And if you didn't want to FOIL it out, and nothing wrong with foiling it out, it's small enough you could do it. But if you didn't want to FOIL it out, what would be the other method?
You could use u substitution with the x plus 2, and it would basically be the same thing as just like to the power of 3, and then it would just change the bounds mostly.
Yep, that's it. You're doing question 11 now. I think the sine x bit is easy. How would you integrate the sine of 2x? I guess -5 sine 2x, but it's the same thing. How would you integrate the sine of 2x?
Just substitute the
Yeah.
2x.
U equals 2x. I think you end up with something like 5 halves sine u. Right? Okay, what would the u sub in question 13 look like?
Would it be pi t over 12?
Yeah, would you agree that's the only thing that it could be, because there's not really much else going on there? Ugly, ugly answer, by the way, so don't be surprised if you get some weird fraction with pi's in the wrong place, meaning in the bottom. Ugly, ugly question. What would you do in 14?
Would you just substitute x plus 4?
And that would turn into a 10 over square root of u, and then you'd have to call it 10u to the negative a half and do a power rule. So a little bit of work, but yes, that's how you would do it. And the last couple are all those watching videos, so I'm not going to do anything about that. So what I'm going to do is one more average value, and we'll call that done, right? That we know how to do average values. And then we'll move on to the last part of that section. So nice, easy section, right? Not too many frills or weird places to go. Let's pick something. Who shall I pick? Oh, why not? Just randomly stopped at question 7, so I'm picking that one. We have the function 6 cosine to the 4th power of x sine x, and we're being asked to find the average value from 0 to pi. I guess I should call it h of, it's going to be 1 over pi take away 0, the integral from 0 to pi of 6, this fella, dx. And I didn't leave myself enough room, so I'll do my working over here. And we already agreed that this was a u sub, didn't we? And it was going to be cosine x. So u sub cosine x. Differentiate with respect to x. What do you get? Negative or positive sine x when you differentiate a cosine? Negative or positive? What do you get?
Negative.
Okay, yeah. Have you noticed that sometimes you differentiate in these questions, right? So you have a little hat, I'm in differentiation mode, then you turn it and you go, I'm in integration. So the crossover looks like that. And isolating by dividing both sides by negative sine x. Isolating the dx. So that's the guy that I'm going to use. So I have 1 over pi, the integral of 6u to the 4 sine x times this guy. And it's always nice when this happens. Isn't that a good sign that you've picked the right u sub when you see something that looks like this? Power rule. I'm going to show you some after I finish this. I always like to convert these things back to the original x's. That way I can put the limits in. That's why I don't write the limits here, here, or here. Because if I did write the limits here, here, and here, shouldn't they be using the values in terms of the u variable? It's not the same thing. So I have 1 over pi, negative 6/5, the cosine of pi to the power of 5, take away -6/5, the cosine of 0 raised to the power of 5. Cosine of pi. What number is the cosine of pi?
-1.
-1.
Okay, so -1 to the 5th is still -1. Negative times that negative. Are you happy that you end up with 6/5 when you're finished? Now, the cosine of 0 is 1, so 1 to the 5th is still 1. -6/5 times 1 is still -6/5, but when you subtract it, you get 6/5. And so you end up with a really ugly fraction with pi's on the bottom. Now I want to show you a little trick. I don't like this trick, but some people do, and I think it's only fair that I allow you to do it if you prefer. When we do a U sub and we get to this point here, we can actually do it there as well. What we want to do is change the limits of integration if it's possible. Now, in this case, isn't x equals 0 to x equals pi? Now, if you're changing the variable to the u fella, which I guess I need to over here, since u is the cosine of x, when x is 0, u becomes the cosine of 0, which is 1. And when x is pi, u is the cosine of x, so it's the cosine of pi, which is -1, which means that you could, and it would be correct to do it, to change the limits of integration to be in terms of the u. Now, if you did this calculation using u is 1 to u is -1, can you trust me that you get the same answer? And some people like to change the limits of integration when they do U subs. And I can understand why they do it, and it's totally okay if you want to do that, because it tends to reduce a little bit of one line of working at least. So if you're interested, why don't I do it that way? I always like to return back to the x's. And there are a couple of reasons. One is I'm careless. There's a surprise. And I very often screw up my limits of u. Second reason is, aren't there a lot of integration questions, not to do with this one, that ask you for the indefinite integral? And when they ask you for the indefinite integral, you have to go back to here and stick a plus c on it. If you're used to doing the U sub, isn't there a temptation to put the plus c here and think you're right when you have to do it this version? And so it just makes it easier to eliminate the chance that you might do that by always returning to the x's. So if it's a definite integral or an indefinite integral, I'm in x's in both cases, it won't be a problem, I'll always do it. But if I sometimes decide to do this technique, isn't there at least a possibility I might forget when it's an indefinite integral question to return back to the x's? So it's mostly, I know what my weaknesses are, and so I try and avoid situations where they happen. But if you like this trick, go for it.
I have a quick question on that one.
Yes.
Wouldn't the limits be switched? So the positive one would be on the bottom and then the negative one would be on the top because cosine's all funny.
You are quite right.
And then, don't you just negate the integral to switch the signs? So that's like messes with the positive and negative.
Well, you could say that, but it works. Haven't I now just convinced you why I don't use the U system? Because I actually just screwed it up there. Yeah, I mean, when x is 0, which is the bottom number, wasn't the u value +1? And then the other guy went there. So now the answer is correct. If I'd stuck to the order I just written, I would have got -12 pi's, which I've just realized here can be simplified. So I have just shown you why I don't do U's. But the fact that you picked up Kira probably means that you wouldn't have the same kind of issues that I would have. So what is the last part of this section? We're going to start it today, finish it tomorrow. It's called the mean value theorem. I think intuitively this, when you find out what it is, you're going to say, yeah, it kind of makes sense. So we start off with our basic function, as we always have. It's going to start here and do its thing. It's a well-behaved function, so we're allowed to do all the things that we'd expect. It starts at A and it finishes at B. And we have the average value. And what the mean value theorem says, MVT for short, it says there will exist at least one value of X, let's call it X equals C, that has the property that the value of the function at C is the same thing as the average value. Right. Can you imagine we calculated this average value and it was 3/4? What the mean value theorem says is, can you imagine this is where 3/4 is, right? It says there is at least one place. In this case, isn't there 3? And we'll call them C, right? There's at least one value of X between A and B that has the property that the value of the function is the same as the average. So can you imagine a function whose average value was 3/4? Would it seem reasonable that there should be at least one place on the curve that has a height of 3/4? That's essentially what this is saying. Intuitively, does that kind of make sense? It's not that weird. You'd expect that to be true, and it is. So let's do one. Pick a nice simple function. That guy. Let's do it in the interval 0 to 2. So if I do a little sketch of what that function looks like something like that. There's 0, here's 2. And first thing we need to do is find the average value. So it's 2 take away 0, then take it from 0 to 2. Tell you what, just to make my life easier, let's make that 3. Because we're running short of time. And I want to keep things simple. Right, we got that. So it's 1/2 power rule. So I changed it to 3. Evaluated at 0 and evaluated at 2. And it's 2 cubed plus 3 lots of 2 minus a whole load of nothings. 8 add 6 is 14. And it's 7. So if you imagine this is 7, would you agree that there is at least one point on that curve? But in this case, there's only one point on this curve that has the same value as the average. So let's find that guy. So what we need to do is we need to solve for what value of X is our function equal to 7, the average value. Now this guy is 3x squared plus 3 equals 7. And I'm going to get this value exactly. And we should try and get it exactly whenever possible. Yeah. Are you comfortable about what we've just done so far? The function equals 7, take away 4 from both sides, divide by 3. Now, what should I do to both sides now to find X?
Square root both
Take
sides.
square root.
I agreed. Square root both sides. Now, technically, when you square root both sides, you always get plus and minus, right? In this particular question, I'm only going to pick the positive 2 root 3. Why am I not going to use as a possible answer the negative value of that? Why can't I also use negative 2 over root 3 as a possible answer?
Because the question already tells us that it's from 0 to 2.
Exactly. So only go hunting for these magic C values, right? That's basically what this is, the C value in that range. Now, this fella here, just because I want to make it look pretty, there it's rationalized. That's the guy they call C. So in your homework, you're being asked to find C. In this case, 2 root 3 over 3. So for the last few moments, I'm going to return and show you what that guy looks like. Here we go. Right, you should be looking at Desmos. Are you looking at Desmos? Okay, let me shrink this thing back a little bit. There we go. Actually, I could do it the other way. I can just make this bigger. That's better. There we go. Can you see the guy we're talking about here? Now, if I put in the average value is 7. Y equals 7. And I click on that guy. Can you see he is 1.155? And do not be surprised that 2 divided by the square root of 3 is equal to 1.155, roughly. So what I'm really doing here is I'm letting Desmos check my exact value. Now, there are going to be situations where you cannot solve, find the missing value of C algebraically. Right? When that happens, well, you just go here and like Desmos. So I'm going to make something up that I know nobody's got a chance of doing. So suppose it was e to the power of x minus sine x, right, which is that guy, and 7. Would you agree that you couldn't solve when is this exactly equal to 7? But can't you do it in Desmos and just click on it and write down 2.064? So depends on the situation. If it's a quadratic, I think you should be able to do it exactly. If it's just a sine on its own or a cosine on its own, don't you have a fighting chance that you could do it that way? If it's some ugly, you know, log u over u squared kind of situation, would you agree you're not going to solve that? So just do it on Desmos and write down the decimal. And that is called the mean value theorem. And say your last name.